In this video, we will derive an expression for length of cross belt drive. Okay, so first we'll see what is cross belt drive. We have two pulleys here. This is pulley 1, bigger pulley, and this is pulley 2, smaller pulley. Okay, there are two pulleys. So in between that, the belt is connecting here to transfer the power. Okay, so belt transfer is in such a way that it will be in cross. Okay, if this is the case, the both bigger pulley and smaller pulley, both pulleys rotates in opposite direction here. Okay, it means if this is the bigger pulley, if this rotates in clockwise direction, the smaller pulley rotates in counterclockwise direction. Okay, anti-clockwise direction. Here this is how the cross belt drive, it will move. Suppose the belt is transferred from here, starts from here, it crosses here and comes in this way, and it will move on the smaller pulley, then it will crosses in this way here. Okay, this is how the cross belt drive, the construction here. First we will go the one by one points here. Consider a cross belt drive shown in figure. Okay, so next point, I said the belt drive is said to be cross if the bigger pulley and smaller pulley rotates in opposite directions here. Okay, the belt drive is said to be cross if both pulleys rotates in opposite direction. Okay, as I given here, this rotates in clockwise and this is anti-clockwise here. Just I'll write this one as the larger pulley, and this is normally known as driver, and this is smaller pulley, and this is known as driven here. Okay, now let us go one by one here. O1 and O2. Okay, O1 and O2, let O1 and O2 are centers of the larger pulley, larger and smaller pulley. Next, I'll give another notation, R1. The R1 is, this is R1 is the radius of the larger pulley, and R2 is the radius of smaller pulley. Okay, so then R1 and R2 are radii of larger and smaller pulley. Okay, next, here L I denoted here. What do you mean by L here? If you see the picture, it is the distance from centers, distance between the centers O1 and O2. Okay, let L equal to the distance between O1 and O2. Okay, these are all the notations, R1, R2, L, and O1 and O2. Next, what are the points E, G, H and F? Okay, this is E, F, and this is G, H. Just I given the notations here. So E and G are the points from where the belt leaves the bigger pulley, the larger pulley. Okay, similarly F and H are the points from where the belt leaves smaller pulley. Okay, so let belt leaves the larger pulley at E and G, and smaller pulley at F and H, at F and H here. Okay. Next, I made some construction here. From O2, I'll draw a line parallel to EF here. Okay, just I made the construction. I'll made the construction here. From O2, just okay. From O2, draw O2M. This point I'm giving as O2M. O2M parallel to EF. Okay. So from O2, from O2 draw a line O2M, that is O2M parallel to EF, parallel to EF. Okay, if we made this line, then obviously this angle is 90 degree. This is 90 degree, and EF is perpendicular to EM. Okay, also therefore O2M is also perpendicular to EF, perpendicular to O1M here. So now the triangle, we need to consider the triangle O1, O2 and M. Okay, it is a right angle triangle. Therefore, triangle O1, O2, M is right angle triangle. Right angle triangle here. So just I made the angle here. The O2M makes an angle of alpha. This is alpha with respect to O1, O2. Okay. Therefore, O2M makes an angle of alpha with O1, O2. Okay. So therefore, that is O1, O2, M is the made an angle of alpha here. So next, now consider the triangle O1M O2. Consider triangle O1M O2. From this, sin alpha is O1M divided by O1 O2, right? That is sin alpha equal to O1M divided by O1 O2. Simplify this one. O1M, I can write it as O1E plus EM. That is O1E plus EM divided by, so O1 O2, what is O1 O2? It is L. That is L here. That is L. Again simplify this one here. So O1E, what is O1E here? The R1, radius of larger pulley. Substitute R1 plus, what is EM here? EM is nothing but the O2F. These two are parallel here. That is nothing but R2 divided by L. Okay. Next, this is sin alpha equal to R1 plus R2 divided by L. Since the alpha is small, sin alpha is also nearly equal to alpha here. Okay. Therefore, alpha equal to R1 plus R2 divided by L. Call this one as equation A here. Okay. This we need while substituting next equation here. Now we'll consider the total length of the belt. Here just I'll analyze here. The total length of the belt equal to arc GJE plus EF plus arc FKH plus length HG, right? This is how the belt will be moving here. Therefore, total length equal to L, that is equal to arc GJE plus EF plus arc FKH plus HG here. Okay, if you simplify this one here, so L equal to, so arc GJE is the 2 times arc JE, right? I can write it, this will be 2 times arc JE. Okay, next plus EF, this is EF plus arc FKH, I can write it as the 2 times arc FK, right? 2 times arc 2 times arc FK plus this GH. Okay, now again this simplify here, 2 times arc JE plus EF and GH. We know that this is EF and GH, both lengths are equal, right? So I can write it as 2 times EF, 2 times EF here. Okay, 2 times EF plus 2 times arc FK, that is arc JE plus EF plus arc FK. If this is one section, again remaining this is one section here, we can dividing here, that will be equal to 2 into arc JE plus EF plus arc FK. Okay, this is the length of the belt here. Call this one as equation number 1. Now we will solve one by one. What is the arc JE and EF and FK here. We'll go one by one here. Okay, now first I'll solve here arc JE here. JE, how we will write arc JE in terms of the R1 and R2 here? We know that the normal, the arc length, what is the formula? Arc length equal to radius into theta, right? Radius into theta. Apply the same here for JE here. Radius is how much? Radius is R1, that will be equal to R1. Now come to theta. Theta is this angle here. Theta is pi by 2 plus alpha, that is pi by 2 plus alpha here. This is arc JE. Now similarly, the what is here I'll write arc FK. Next I'll find out arc FK. Okay, so FK, where is FK here? This is FK. So for this one, what is the radius here? The smaller pulley radius is R2, that is R2. The theta is how much? This angle. Theta is this angle. Again this is here, this will be the alpha here, pi by 2 plus alpha, same pi by 2 plus alpha here. This is arc FK. Now this is finished and this is finished now. Now come to the length EF. We need to calculate EF here. That is EF equal to, this EF equal to, can I write it, the length MO2, both are same, both lengths are same, that is MO2. So how to find out MO2 here? MO2 is consider the right angle triangle here. O1, O2, M. O1, O2, M. From this, MO2 equal to square root of O1, O2. This is O1, O2 square minus O1 M square, right? O1 M square here. So this is the right angle triangle here. Substitute, if you find any values here, this will be square root of, what is O1 O2? O1 O2 is nothing but L, that is the length of the centers, L square minus, what is O1 M here? O1 M is O1 E plus EM, that is O1 E plus EM square, right? Again simplify here, this will be L square minus, what is O1E here? O1E is the R1, radius of the bigger pulley, that is R1 plus EM is nothing but your O2F, both are parallel here, same distance, that will be equal to R2, that is R2 whole square. Okay, next this is EF. Again simplify, take L outside here, that is 1 minus R1 minus R2 divided by L whole square. Okay, R1 plus R2, this is R1 plus R2 divided by L whole square here. Now expand this equation by using binomial theorem. Okay, so expand above equation by using binomial theorem. Okay, I am expanding here, that is EF equal to L into bracket 1 minus half of R1 plus R2 divided by L whole square plus so on here. Okay, this is how use the binomial equation and expand this here. This will be equal to, simplify L minus R1, because the L you can take inside, R1 minus R1 plus R2 whole square divided by 2L. Okay, this is EF. Now if you see here the equation 1, now come to the equation 1 here, substitute one by one. What is equation 1? Therefore equation 1 becomes L equal to 2 times first arc JE. Arc JE, how much we calculated here? Arc JE is 2 times R1 here, R1 into pi by 2 plus alpha. Okay, next plus, what is the EF here? EF we derived already. EF is L minus R1 plus R2 whole square divided by 2L. Next plus arc FK. Arc FK is here. Arc FK is here, that is R2 into pi by 2 plus alpha here. Okay, now go on simplifying this one here, we will get this will be equal to 2 into R1 pi by 2 plus R1 alpha plus L minus R1 plus R2 whole square divided by 2L plus R2 pi by 2 plus R2 alpha here. Okay, again simplify this one here, 2 into, so here R1 R2, that is pi by 2 R1 plus R2. Okay, next here alpha plus alpha into R1 plus R2 plus L minus R1 plus R2 whole square divided by 2L here. Okay. Again simplify here. This will be equal to 2 into 2. Again simplify this one here. That is pi into R1 plus R2 plus 2 alpha into R1 plus R2 plus 2L minus R1 plus R2 whole square divided by 2L here. Okay. Next simplify this one. We will this is L. Now we know that here alpha 1 term is there. We already calculated what is the alpha value here. That is alpha before we derived the equation here. That is alpha equal to R1 plus R2 divided by L. Substitute this alpha here in the total length equation. That is substitute alpha equal to R1 plus R2 divided by L from equation A. Okay. Therefore L equal to pi into R1 plus R2 plus 2 times substitute alpha value R1 plus R2 divided by L here, again into R1 plus R2 plus 2L minus R1 plus R2 whole square divided by 2L here. Okay. Simplify. This will be equal to pi into R1 plus R2 plus 2 into R1 plus R2 whole square divided by L plus 2L minus R1 plus R2 whole square divided by 2L. Here if you take 2 inside, this 2 will cancel, so that here we'll get the L here. Again continuation here, we will get here L, so here also we'll get L here. Okay, so this is L. The final, again if you simplify, L equal to pi into R1 plus R2. So here 2 and here 1 is there, it will goes plus, this is, I will take first here 2L plus R1 plus R2 whole square divided by L. Okay, this is how the total length of the belt, cross belt. If you analyze the belt here, the 2L first we will take. Here EF and GH are the two lengths. L plus L we will get 2L here. Next again for bigger radius it will be pi into this much. This is GJE, that is pi into R1 plus R2 we will get. For smaller radius, that is R1 plus R2 whole square divided by L here. Okay, this is how the total length of the cross belt drive. From this equation, the equation is mainly dependent on the R1 plus R2. That is the L is the function of R1 plus R2. Therefore, above equation, from above equation, L is a function of R1 plus R2, right? So what it mean? That is radii of both pulleys. If R1 plus R2 is constant, then the length of the cross belt also constant, provided the distance between two centers, that is L is constant here. It means if L is constant, R1 plus R2 is constant, then this is small l. Small l means small l is the distance between O1 and O2. If this is constant and R1 plus R2 is constant, then the length of the capital length of the cross belt drive is constant here. That I will write here. If R1 plus R2 is constant and L, that is O1, distance between O1 and O2, distance between O1 and O2 is constant, then L, that is length of cross belt drive, cross belt, is also constant. Okay, this is the rule we need to apply here.